All right, I get this lucky spot, 1 o'clock. If you guys fall asleep, it's not the talk, it's the food and the time. So I'd make you all do push-ups or something to wake you up, but I don't think there's enough room in here, so we're just going to get into it. We're going to do a pop quiz first. Who could tell me what this is? It's a web browser, right? It's a web app. Okay, another one. What is this? It looks the same, but it's not. This is a hybrid app. So if you've come to this talk wondering what a hybrid app is, this is what a hybrid app is. It's basically an app. There's an app that runs in the browser, an app that runs on a native desktop client, and the one on the right is the hybrid app. It looks essentially the same because it's, for the most part, exactly the same, right? But one's a native desktop app, and that's what we're going to dive into. My name is Rich Manalang. As Grace said, I've been around for about 5 years at Atlassian. So happy to be in Barcelona. It's been a while since I've been to an Atlas camp, so I'm really excited about this. For the next 25 minutes, we're going to dive deep into the world of hybrid apps. But before I start, how many people here are familiar with or built a hybrid app before? Okay, a few people. Good. Okay. So anyone familiar with this app? This is Spotify, right? So if you've used Spotify before, you probably don't care, but this is actually a hybrid app. And what makes it a hybrid app is it's built entirely, almost entirely, with web technologies, HTML, JavaScript, CSS. And as a matter of fact, if you crack open the Spotify app, you can do this simply by doing the show package contents inside of Mac. You can go in and crack open one of these modules. They call them the SPA files, and it's basically an archive file. You crack it open, and you look at this, and you're going to see a very familiar thing if you're a web developer. You're going to see HTML, JavaScript, CSS. And the really cool thing is Spotify doesn't even bother to obfuscate any of their code. There's no minification, nothing. You even have access to all the build files, the grunt files, and everything. So if you wanted to modify Spotify, you could probably do it. So Spotify kind of popularized this. I'm sure there are others that have come before Spotify, but Spotify is probably the most prominent one, and simply because of their size. And so the way they build their app is actually really cool. Each component, each module inside of the Spotify app, each square is a web app, right? You might have the album listings, that's a web app, and then you might have the main center point piece in the app, that's another web app. And they load those in as iframes. Let's look at a few more examples. Visual Studio Code. How many people here are familiar with Visual Studio Code? This is not Visual Studio. It's Visual Studio Code. Code is their light version of Visual Studio. It has some really cool features that Visual Studio has, things like IntelliSense, but it's really made for a different crowd of developers. It's made for JavaScript developers, or if you're coding in Go, or Python, or any scripting language. It's a great IDE. Text editor, I wouldn't even go as far as calling it an IDE, but it's a wonderful text editor, and it brings all the great pieces of Visual Studio to the masses. Here's another example, and this time it's not a full desktop app, right? It's this tool, One Clipboard. It's a simple little clipboard app that basically maintains your clipboard. So anything you copy gets synced up to Google Drive and gives you access to it later on. And the cool thing is it looks like a native app, but it isn't. It's a hybrid app. It's all JavaScript, CSS, HTML, and it runs on your system tray. It's not like a window-based type of app. So you're probably wondering, why do we even need hybrid apps? Well, it's not obvious from this picture. I was kind of thinking, you guys remember Dolly? the clone sheet, that's what made me think of that. It's kind of a hybrid. The biggest advantage of having a hybrid app is really about kind of the composition of your team, right? How many of you know how to code in Objective-C or C++? Okay, a handful of you. But how many of you actually know how to code in web technologies? Whoa, look at all those hands, right? So that's the main reason, right? You want to be able to ship your products faster. You want to be able to build it with the same team that you already built your web app with. And so that's the main driver of building hybrid apps. I mean, there's other drivers too, right? But for me, that's the main driver. So how did I get into thinking and working about hybrid apps? For me, it all started back in 2014. I joined the HipChat team. So as Grace mentioned, I've been here for a while. I've worked on add-ons. I've done DevRel. I've done all kinds of stuff. In 2014, I wanted to go back into engineering, so I went into HipChat. And immediately when I went into HipChat, one of the things I discovered was a real pain was that we had, on the desktop, we had 3 clients. We had web, we have Mac, we have Linux, and Windows, of course. So really 4. But at the time, Windows and Linux was running. It was being run by a team that was writing in Qt. And their one team putting out for those 2 operating systems. We had a Mac team that built a new Mac client, and we had a web client. And at the time, no one was maintaining the web client, which was kind of sad because the web client was, it's a prime place for all innovation. So, and the also interesting thing about the web client at the time was it was actually pretty simple. It's like 7,000 lines of code. For a web, I mean, chat products are actually really not that hard to build. They're pretty simple, right? So 7 files, 7,000 lines of code, 7,000 lines of jQuery code that serialize and deserialize XML going in and out of the servers. It was pretty ugly. It was spaghetti code. And so I lobbied pretty hard to change that. So, at that time, there was no formal project to say, okay, we're going to rewrite the clients because we wanted to have one code base for all of this stuff. Basically, I took one other developer that was working, one of our front-enders, and said, hey, let's spike something. And at the time, React came out. React is a project, a library from Facebook that kind of came from Instagram. And you guys have, I'm sure, have all heard about React. It's a popular thing these days, like the new hot thing for JavaScript. So we took React and spiked something on React, and shortly thereafter they announced Flux. Flux is a kind of a unidirectional flow library. It helps you basically maintain sanity in your code. It made it easy to kind of reason about your code so that new developers who got onboarded onto your project kind of knew what they were doing, which is a big thing for JavaScript developers because it's kind of like the Wild West when you're working on front-end projects. So, but at the time, Flux wasn't a library. Flux was a specification. So Facebook didn't release a library up until a few months later down the road. And so we ended up writing our own Flux library, our own implementation of that. Today, if I were going to do it again, I would change things. There's a whole bunch of these Flux-based kind of libraries out there now. Redux is like the main one that people have gravitated to. But I would also go a step further. I would go way beyond that. I would plan to not just write a web app. I would actually plan to write a desktop app, right? This is probably the single most important thing out of this whole session that you're going to find is that designing a desktop app is way different than designing and building a web app, right? And that is something I learned in the 2 years I worked at HipChat, that it's not easy. And there's a bunch of things that you have to think about. We didn't plan well in the beginning. Like I said, we were rewriting the web client. with the hope of like maybe potentially someday building this out as a desktop client. But we didn't know what to plan for at the time. So, like the main reason it was hard for us to move to our web app to a hybrid app was because we were really thinking like web developers still, right? We have, I'm a web developer. I've never built desktop apps prior to that. The guy I was working with is a web developer. And, honestly, your frame of mind needs to change when you build desktop apps. Are you guys familiar with the uncanny valley? So there's this thing called uncanny valley. It's a phenomenon where things that appear real but aren't kind of make you feel unsettled, So like this came out when Japanese robotics, they invented these robots that look like real people. They look really real, like wax figures. I mean, almost like real. But people would walk by these people, and they would notice something. It's like, oh, they're not real, right? So it made you kind of feel weird. So I took that whole uncanny valley, and I'm going to show you kind of like the distinction between hybrid apps and real apps and how that fits into the valley. We're all familiar with this thing right here. This is a browser. It's Google. We use it every day. Very familiar. It's a known quantity. And then there's other types of apps. As browsers have really become more powerful, there are all these apps now that we use. I mean, Gmail was probably the first one that became like this app that was like blew people's minds away, because it wasn't just this app where you click from one page to the next. It was an app that sat in your browser for a day, maybe more. It was a desktop app, right? And so there are a lot more of these now. This is Apple's Numbers app, which is a web app, but there's also a desktop app component of that too. And likewise, there's a Keynote version of this as well, right? And it's a web app, right? And then there's the native app version of Keynote, which is what I used to create this presentation, right? Very familiar. You use native apps basically because they're fast and they're responsive, and you know what to expect out of them, right? So, you're probably wondering, so like this valley right in the middle here, this is the uncanny valley. What fits in there? What kind of apps fit in there? Well, let's look at one. So Google Music. Anyone here use Google Music? So great, one person. Google Music is great. But Google they don't make a native desktop app for Google Music. It's just on the web. So there's this company or product, I don't know if it's a company, but there's this player out there called Radiant Player. It's a hybrid desktop app that wraps Google Music, right? And it's pretty cool. And we'll dive into it and let's see what it looks like. So you click, and you click on this stuff like as if you're just launching a native app. But one thing that's weird about this is like, why are there two sign-in buttons? Somehow there's an extra sign-in button that got introduced there because it just wasn't well planned. I mean, one problem with that is because, and then there's another problem here where it's prompting you to install Flash. That feels kind of weird, right? Why would I need to install Flash if it should have been installed to begin with? And then lastly, why is it prompting me for ads? How many desktop apps do you know prompt you for ads? Anyone? Oh yeah, that's true. That's true. So that's weird. I think that app fits in that uncanny valley, and so that's the app that you want to avoid as much as possible. If you're creating these things, you don't want to make your app feel like a web app, right? Let's talk real quickly about the tools to create these things. There's lots of them. There's a lot more than that's on the slide. But these are the ones that people generally know if you get into this thing. There's tools that target only specific operating systems like .NET, C#. If you're on Windows, you can use those tools. So, for us, we're writing for all of them, Linux, Windows, Mac. So that's out of the picture. Node WebKit is another one. It used to be very popular. It's been kind of replaced by Electron. There's another one called Qt. And Qt is actually really good. There's a lot of apps out there written in Qt. And Qt is not just a hybrid framework. It's a full desktop framework for building desktop apps. But the one thing with Qt is it kind of lags behind the times. The browser component in it, it's usually lagging what's currently available. So OK, that's out. And then you're left with like the true native frameworks, like Windows. With Windows 10, they have a really great framework now called Universal Windows Platform, which truly allows you to write once for desktop, mobile, and your tablet. But if you have a Windows mobile phone or a Windows tablet or a Windows desktop, it doesn't allow you to do it for Mac or any other operating system. So really, oh, and the same thing with the Mac side. So on the Mac side, you have the Objective-C in Swift only targets Mac. So there's only really one solid choice these days, and it's a project called Electron. And Electron came out sometime in the spring last year, and it just hit 1.0 about 2 weeks ago. It's a wonderful project, and Electron is gotten so popular now. So Visual Studio Code, the one I showed, the editor I showed you earlier, is written with Electron. This is Electron API demo app. And here I'm just cycling through a bunch of native capabilities Electron provides out of the box. Things like customizing menus, opening system dialogues, putting your app in the tray, or taking screenshots. It's pretty rich. There's a lot you can do with it. And the best part of this is Electron is the API behind it is all JavaScript. So if you're a web developer, you know JavaScript, you can start building desktop apps today without having to learn anything new. But regardless of hybrid app frameworks you choose, whatever you build isn't really native unless you can trick the user into thinking that it's native, right? You want to follow kind of like what Spotify did, where when you download Spotify and you start using it, you have no idea if it's a native or web-based app. You don't really care as long as it works. And to do that, you really need to be able to respond to certain things. Like for HipChat, we needed the ability, like these features up here, which are provided by Electron, by the way. But one of the things I want to highlight on this slide is the idle time detection. So idle time detection in a web app is actually pretty challenging because there's no real APIs for idle time detection in a browser. You have to do like set timeouts and then crazy kind of algorithms to try and figure out whether or not the user is truly idle. And in the browser, a user is idle when they stop doing anything on that page. So if you tab over to another tab or use another app, it considers you idle, right? That's not really the definition of idle that we want. The definition of idle we want is, has the user left their computer, right, away from keyboard, AFK, or network reachability, right? If we want to know when either the Wi-Fi is turned off or whether we can't reach HipChat.com, which is it, right? And the browser can't tell us that. It's very primitive. So we need low-level access to like operating systems telemetry APIs. The nice thing is Electron actually provides most of those sensors to you as part of their API. So you get a lot of that out of the box. All this kind of brings back a point I made earlier about thinking like a web developer. As a web developer, we hardly ever have to worry about how long a user keeps your app open, right? And if you're building a web app, most web developers most problems on a web app can be fixed by a refresh, right? It's like, oh yeah, someone calls you, something's broken. Oh, just refresh the page, right? Well, here's the thing, you can't do that in a native app. There's no refresh button. They also don't have things like sessions, so for session cookies. Actually, that's a lie. You can actually get by and add session cookie support in native hybrid apps, but I strongly suggest you don't do that. But what do you do when something goes off, when the network drops, when it's offline? Or have you really spent much time thinking about how fast your app launches, like your web app? A lot of us do these days, but if you're comparing a web app versus a desktop app and you launch it, a desktop app is instantaneous, right? You don't get a blank screen. So you want to try and mimic that as well. So all these things are things that you have to kind of build in when you're designing these things. Okay, stop being a web developer and start thinking more like a real desktop developer if you're going to do this. In a native app, you absolutely have to think about all these hard use cases because they're not edge cases anymore. And building desktop apps is all about building resilient apps, apps that can survive the state of anything that you throw at it. Network dropping off, power coming off your laptop, losing batteries. What do you do, right? In a web app, you can't really survive that unless you build that in right from the beginning. So to help you think more like a native developer or native desktop developer, let's start looking at the two main hybrid app strategies. The first strategy is probably the easiest. You can build a client that is served directly by your web server, just like what we saw with a Google Music player. This way, your hybrid shell is just a shell. It's just another browser. The actual app just gets loaded. When you start it up, it goes out and makes a network request, gets your app, brings it to you. Let's take a look at that real quick. So there is actually another Google Music player out there. I guess this is a popular thing to do. It's to wrap Google Music player. Google should just build one. So there's another one out there called Google Music Desktop Player. It's a nice hybrid app. It's an open source app, and it's built on Electron. And while it's web-based player is nice, users really would probably prefer a really nice working native app. So let's look at this real quick. This is in a Mac. One thing that's weird, though, about this particular player is that they've changed the Chrome. And I think this is probably for Windows and Linux support, that they wanted to provide a custom Chrome. But you can actually switch it to the Mac Chrome. But one of the things that they've added to this is they've added all kinds of things that's not available in the Music app, in the Google Music app. They've added theming support. They've added all kinds of things that you can modify. Oh, I just restarted it, and this is basically bringing up the standard Mac Chrome around it. But you notice it didn't ask me to install Flash. Yes, ads are still there, but other than that, it's a nice experience. It works pretty well. And the nice thing, too, like I said, is it's open source, so you can go out there and clone it. If you want to look at an example, it's a great place to start. But what happens when you're offline, right? You're offline, you're in crazy conference Wi-Fi, and you bring up the app, and nothing happens. You get the blank screen. Probably not a big deal for people who use Google Music because it's, you kind of know that it needs to network, but providing a white screen is probably not a good experience either. So let's look at what Spotify does. So Spotify, again, it's a hybrid app, but in an offline state, it doesn't do that, right? Because it's not fetching resources from the network, right? So it'll come up. Most of it's disabled, but you can still do things, and it'll tell you that it's offline. So that's one way to respond to the user, right, when something's offline. This actually even lets you play music that you have on your hard drive rather than just being completely useless. So how do we fix this problem? Well, the other strategy is to host your assets, all of your app, HTML, JavaScript, CSS, all of it inside the actual binaries for your native app, right? Now, the thing with this, and actually this is how HipChat is distributed today, is the problem here, and this is a problem that we've discovered ourselves, is that your code now lives in two places. You've actually forked your code, right? Two different ways to deliver it. One on the web, one on the desktop. So now you have version inconsistencies. You have to think about like how you make updates to your server, because if you make changes to your server, it could potentially break your desktop app or an older desktop app if someone hasn't updated. It gets very complicated. So let's try to avoid that. How do we fix that? So last year, Alex Russell, he's from the Google Chrome team, he wrote this blog post about certain traits of resilient apps. And since then, Google has coined this as progressive apps. And if you watched Google I/O last week, this was a huge topic for their web developer track. So they wrote about these progressive apps, and basically they kind of took certain things about certain things like instant loading, and also, by the way, to Google, these progressive apps are mainly targeting mobile use cases. So you're going to see things like the ability to add it to the home screen, push notifications, that type of stuff. All these things apply to mobile, sure, but they also apply to hybrid apps. The main thing that I want to talk about real quick is that in the main thing the main new tool that Google announced is this thing called service workers. Service workers is an API that you can build, that you can use in the browser, that basically acts as like a local cache proxy. And so when you're offline, you can react to requests that happen inside of your app. So let's just look at that really quickly. So here's an example of a progressive app that Jake Archibald from the Google Chrome or the Google Dev Advocate or DevRel team put together. It's a sample Wikipedia app. So this is a web app. We're looking at the web app. And on the bottom here, you can see that there's actually tooling inside of the dev tools for this. So you can actually inspect it and do things. What we're going to do is we're going to take this app and we're going to take it through its paces around like being offline, online, and see what happens. So we've marked this article to be offline. Now we went offline. We took our Wi-Fi off. And you can see you can still bounce around the app and you can still access the articles. Now what we're going to do is we're going to take Electron as a shell, and basically we're going to take that app that's living somewhere on the internet and add it into Electron. So this is cool about Electron. Like I said, it's all JavaScript, right? We're going to go in and add a web view, which is basically like an iframe. And the only difference between a web view in Electron and an iframe is the fact that a web view runs in a separate process. You start that up, and then there's your hybrid app right there, right? So what we're going to do is we're going to take it through paces again, mark things offline, and we're going to look up Donald Trump and mark him offline, and then we're going to go offline and see if he's still available. So, and it still works. It's great. You can do that. And now let's see what happens when you try and access something that isn't there, isn't in the cache. You don't get a 404 error, right? Which is a nice experience for the user. You get told that network's out. You need to turn the network back on for me to be able to access that. We're going to turn the network back on. You can see that it's going to respond very nicely, and as expected, there's your article. So that's a great example of taking an existing web app and turning it into a native app. So after seeing this, how service workers can solve like our resiliency problem, does it even make sense to go with the other strategy where you have locally hosted assets? Well, here, in my opinion, I don't think so. Like if I were to write the HipChat app again, or any app all over again, I would go with this strategy first. So to sum it up, here, if you're going to write a hybrid app, 3 main points. Plan accordingly. Build a progressive web app right from the start. Use service workers, and make your app as resilient as possible on the web. You don't need to build a desktop app to make your app resilient. Use Electron. Electron is a great tool, huge community behind it, and it's really easy to use. Just go for that. And then lastly, start thinking more like a desktop developer, right? Not like a web developer. Think about like all these use cases, like how long are people going to have your app running for? So, you know, like HipChat, people leave HipChat running for days, months, you know, and, you know, you got to think about like memory usage and all those things. So that's it. Thank you.